Okay, so today we're going to be talking about finding the area of circles. Wait, we did that last chapter, didn't we? Or 2 chapters ago. Well, the area of circles in sectors. What I mean by that is this. We are going to look at a circle and we're going to say, okay, we can find the area of the whole circle, or we can say, let's find an area or the area of just a sector, which is like a piece of pie cut out of that circle. It's a fractional portion of the circle. Okay. And so we can do that. We just can take a fraction times the entire area. And so that's what we're going to be looking at today is, can we talk about that? Our kitty cat is eating a little snack behind me. So if you hear a little crunching, that's our kitty cat. Okay. So the deal is, today we're going to be talking about circles again. And a reminder, a circle is a set of points that are equidistant from the center. And so we graphed circles 2 chapters ago where we're like, okay, if you go to the center, which is H and K, and then we go out from there, this value here, that's radius squared. So the radius equals 5. So if you go 5 in each direction from the center. Good morning, kitty. Hi. Then she wants me to play with her. And so the thing is that this is a graph of the circle that is written on the left. And so remember, the radius is the distance from the center to any point on the circle, and it's consistently the same value for the same circle. The diameter is the longest chord. It's the distance that connects one side of the circle through the other, through the center. And if you have two congruent circles, they're equal radiuses, okay? They're equal size, so you could try to draw. Hi, kitty. And then the circumference is the length around the circle. Remember, we do circumference equals pi times d. A lot of times, we leave our answer in terms of pi because pi is an irrational number that you have to round, but sometimes I say we'll round to the hundredths. Always label the circumference in terms of like a linear measure, like inches or feet. Because if you ran around like a circular lake, you're like, I ran 3 miles or I ran 2.5 miles. And so circumference is the length around a shape. Area, however, is the space inside of a shape. And then that's what I know. Area is going to be like in units squared. Is how many square units are within a figure. Because the diameter is 2 r's, you can also use pi times not just diameter, you can do pi times 2r or 2 pi r. That will also give you the circumference of a circle. I like to use this one because it has fewer letters, but you can use whatever you want. Either one. How they came up with pi is they measured the length around a circle and they measured the diameter of that same circle. And anytime you do that and you divide those numbers, you get pi. Okay, it's the ratio because the shape of a circle is such that they're all similar to each other. And if you take the circumference divided by the diameter, and that diameter is spelled wrong. There's an E missing in that word, but diameter, then you're going to get pi each time. And so it says, okay, please find the area and the circumference of each of these circles in terms of pi. So the exact form, whenever I use an equal sign, that means give me the exact value, unless I say round it. And then approximately implies that you have had to round off to do that. So I suggest that you use that. If you ever have to round, use the approximately sign instead of approximately equal to, instead of just equal, because if you round off, it isn't exactly equal to that value. So the circumference equals pi d. And so if this is the radius of 5, then that means the diameter equals 10. So we're going to do 10 pi, and we're going to label it centimeters. And if you take your calculator and do 10 times pi, you're going to get 31, and it says round to the 10th. So that's 1 decimal place. So it'd be 31.4, and that's also centimeters. The area is equal to r squared pi. I don't know if that's on here at all yet. Area equals pi r squared, or r squared times pi. That's how I normally do it, is r squared times pi. And so for the area, since the radius equals 5, you're going to do 5 squared, which is 25, and then pi, and then that's going to be centimeters squared. So the label, oopsie, I did not mean to cross that out. Trying to highlight. That's the answer for the area, and then the label is centimeters squared. So if you do, you can do 5 squared and then times pi, you're going to get approximately 78.5, not centimeters squared. Again, the answer is 78.5, and it's approximately because we did have to round off. Even your calculator isn't giving you all the decimals because remember, pi is an irrational value that doesn't end or repeat. Now, for the next one, circumference equals the diameter is what they give you here. The radius would be equal to 6 feet. And so the circumference is equal to 12 pi, and that is going to be feet. Again, the answer is going to be 12 pi, and then the label is going to be the linear unit. Okay, the length around this would be the product of 12 times pi, and you get about 37.7, and that would be feet. And then area would be the radius squared, so 6 squared times pi, which would be 36 pi, and that would be feet squared. And then if you put that in your calculator, 36 pi gives us 113.1, and that's feet squared. Anytime you have area, area, it sounds alike, but the reason why it is it's how many square feet or inches or whatever are inside a figure. When you buy a house, they sell you how many square feet, and they charge you by how big it is and how nice it is. Okay, this is review, okay? So this is review. Define the length, okay, of an arc. Okay, you can look at a circle and be like, oh, this arc right here is 60 degrees because it's all the way around would be 360. So this arc right here is going to be just 60 degrees of it. And you're like, that's kind of lame as to how to talk about it. We talk about that sometimes because it is true. But if you want to find the length of the arc in linear units, like how many feet or how many inches, etc., you're going to write this fraction. How many degrees is it out of the circle? What fraction of the circle is it? And you can just, if you're like, it's halfway around the circle, you could write a half there. If it's 60 degrees out of 3, just you have to say proportionally, what fraction of the circle is it? If you ran around the circle 3 times, you just put a 3 there. So it's how many of the circle are you going to do? Are you going to do a part of a circle? Are you going to do multiple times around the circle? What are you going to do? And times the circumference. Okay, so how far did you go if you went from A to C? So the measure of AC is going to be 60 degrees out of 360. That's the fraction of the circle you're going to be going around, and then times the circumference. And it says the diameter is 20, so it'd be 20 pi. And it says I want the exact value and I want the approximate value. And remember, to do the exact, all you do is you take your calc and you put the numbers in, okay? If you don't have a graphing calc, put this over 1 times the top times the bottom, and that will be your fraction that you've got, okay? And so you could, let's see, we do alpha y equals to get a fraction, and you have a fraction key in your calculator, so you could do 60. My calc is being a little bit sluggish, over 360. And we're going to times it by 20. And again, if you don't have a calculator that does this, put 20 over 1 times the two numerators times the 2 denominators and reduce that fraction. That will be your first answer. So my fraction is 10/3, and I'm going to bring this pi over here too. And then the linear length between here and here, because we're talking about inches, is going to be in inches. And so to figure out what that is, I am going to take this value here, and I'm going to take it times pi, and evaluate what that is, and you're going to get approximately 10.5. What's it say round to? It doesn't say. Okay, so 10.5, and that's inches. So this answer here, when you just multiply it out, is 10.5. And that kind of makes sense. And then I meant like proportion. Like if this is 20 inches here, this is about 10.5 inches. All right. And then the next thing is we're going to try it again. Okay. So if you were in class with me, I'd be like, okay, let's try this. You guys try it. See, can you find the length of this? Okay. Not it's 134 degrees of the circle. Okay. That's true. But it's just, I want to know the length of it in centimeters. And so to do that, you say, well, what fraction of the circle are you doing? You're doing 134 out of 360. If you were doing halfway around the circle, you could write a half. If you're running 3 times around the circle, you could put 3. Okay, so you're timesing that times the circumference. The circumference would be pi d, so it'd be 16 pi, because that's the radius. And then to get the exact answer, we are going to just take the numbers and put those in our calculator and figure out what is that. Again, if you don't have a calculator, you can just times the top, times the bottom, and then reduce it. And so I do have a calc, so I'm going to show you how I do it. And then 134, alpha y equals enter gives you the fraction. And just type the numbers in. And if, you can put 16 over 1 if you need to. This is 268 over 45. And that's pi. And then that's going to be inches. Nope, lies. It's going to be centimeters. And then this is not the most friendly number. You're like, I don't know what that is. So, well, let's just figure out what decimal it is. So take that fraction and then times it by pi and use the pi key. And then that is approximately 18.7, and that is going to be centimeters. So this is review, but sometimes we review because sometimes you're smarter than you were when we learned it the first time. And so feel free to ask questions, be like, wait, I almost get it. Where is it? And so that cyclic nature of math sometimes is helpful, especially if you get an opportunity to kind of practice it again, to learn it again. And so we're going to do a similar thing here where say, instead of finding the entire area, I'll ask you the entire area sometimes, but now I'm like, I don't want to eat the whole pie. Let's find a fractional area of a circle. And so how you do that is you take, well, what fraction are you trying to do of the pie? Okay, and then times it by the area. Okay, so how many square inches are it just in that part? Or how many square feet are within that part? And so you write the fraction of the circle and times it by the area. If you were trying to find the circumference, a part of the distance around it, that would be fraction times the circumference. But we're trying to find a fractional portion of the area of a circle. And so, yeah, that's how you figure out things is times the fraction times the entire. Okay, what fraction of the whole are you going to need? And so the radius squared is 12 squared and then pi. And then I'm going to ask you for 2 answers. One is going to be the exact, where you just plug these in your calculator. And then the other one is where you plug all of them in the calculator. So I'm going to take a fraction. Oopsie, I did not want that. And then we're going to do 131 over 360. And then we're going to times it by 12 squared. And you can put it over 1. You can times it by 144. It's the same thing. But your calc is pretty good at figuring out stuff. So 262 over 5 pi, and that is going to be meters squared. So your answer is going to be this part, okay? And the label is meters squared. Again, anytime you find area, it's how much space is within a figure. And so then we take 262 over 5, and we're going to times it by pi. And then that'll give us how many square meters are within this figure. It would be about 164.6. 62, okay, because it says round to the 100th, that's 2 places, and that would be meters squared. Okay, so to figure out portions of things, you take a fraction times that. If you're going to do multiple circles, you could say, I want to eat 3 of these, so it'd be 3 times the area. And so that's how you kind of calculate how big stuff is. Okay, number 4 says, if you have a pizza, okay, a circular pizza, not a rectangular one. We had rectangular pizza last night, but if you have a circular pizza with some crust and all pepperonis on it, okay, here you go. And the diameter is 12 inches, okay. It's cut into 8 slices. What is the area of one slice of pizza? Okay, so if you cut into 8 slices, okay, and we're just gonna say, what is the area of just one of them? Okay. And so that's an eighth of the pizza. You don't have to go to degrees. It's just what fraction of the circle do you need? So sometimes we express a fraction in terms of, out of 360, because that's the easiest thing for us. But you could talk about a half, you could talk about an eighth, you could talk about a fourth. And so all you have to know is what part of the circle. Okay. And then the area is going to be, if the diameter is 12, then that means the radius equals 6. So it'd be 6 squared times pi. And so it says the area, it says round to the nearest hundredth. Okay, they don't want the exact value. So we're going to just do alpha y equals enter. I'm going to do 1/8. I'm going to times it by 36. That's 6 squared. You could type in 6 squared if you wanted to. And then times pi. And we're going to get an answer of 14.14, and that is going to be square inches. Okay, and it says, what would that mean? Okay, what would that mean? That means kind of how many bites you would take. Okay, if you take a bite that's roughly an inch by an inch, that's how many bites you would have, about 14 bites in a slice of pizza. If you take a bigger bite, you're gonna have fewer. Okay, because you can think about how many bites you could take on a piece of pizza, if they're a square inch. That would be an inch by an inch. Okay. The arc length, okay, and so the arc length is going to be the length of this arc just of one piece of pizza. So that would be the length of the crust, if you think about it. Okay, what would the arc length? That would be how much crust you have. How many inches of crust would be from one side to the other. And so we could do that to say, get rid of this. It's still an eighth of the pizza, and then it would be pi d, because we're saying what is the length of that arc? Okay, what is that? It'd be 12 pi, and so we could do 1/8. I did not want that. Alpha y equals, and then we do 1/8, and that would be times 12 pi. And then our answer is going to be 4.71. And that'd be how many inches around the pizza you'd have. Okay, that'd be the length of the crust. And so now we are going to work backwards. So we did again a little of that last chapter. We're going to add one more abstract piece to this. Here we go. It says, if I give you the area, can you find the radius and the diameter? Okay, so area equals pi r squared. Okay, they give you the area. Okay, so leave off the units. We would say this is 144 pi equals pi r squared. If you're trying to solve it for radius, we're going to divide both sides by pi to cancel this out. Divide this by pi. Because there's a pi on the side, it will cancel. If it didn't have a pi, you would have to take 144 divided by 3.14 or the pi key in your calculator. But because it cancels out, you don't have to use your calc for this part. So 144 equals r squared. To get plain old r, we're going to square root both sides. R equals 12. So r equals 12, and that would be centimeters. That's where you grab the units. And the diameter would be times 2. So it'd be 24 centimeters. Now here's where it goes a little more abstract, and I don't love the font here. The area is this. Okay, we've got a letter in there. The label is centimeters squared. So we're going to ignore the label for now. We'll label answers, but so the area equals pi r squared. And this one has a friend in your test, so just breathe. It'll be fine. 25x squared pi equals pi r squared. So let's look at this. So I ignored the label, which is just that centimeter squared. I took the entire rest of it. Yes, it has an x in it because they're trying to get us to think abstractly. And to solve for r, we're going to divide both sides by r. to get the r by itself. So divide by pi. Because both sides have a pi, we can just divide it out. And then you get 25x squared equals r squared. How do you get rid of the squared? Well, we square root both sides. And when you're square rooting something, square root of 25 is 5, square root of x squared is x. So that is what r is. It'd be 5x, and I guess our label would be in centimeters. So our answer is 5x. The label is centimeters. And if we times it by 2, you're going to get 10x. And that's still centimeters. So it's a little weird. We're trying to get you to think abstractly, okay? Rather than concretely, where just the numbers are the answer. So in terms of x. All right. The next thing is, it says, can you do number 7, but do it in radical form? Okay, so let's try this one. They give you the area, and again, this is the area. The label is inches squared. So area equals pi r squared. The area is 18 pi equals pi r squared. We can divide both sides by pi. Cancel that out, divide by pi. Because there's a pi on both sides, it will cancel. Otherwise, you'd have to divide it on your calc. So you get 18 equals r squared. When you square root both sides, you get r equals the square root of 18. Can we break it up? Of course, 9 and 2. 3 root 2, that's the radius. 3 root 2, and that is, it looks like inches. And then if we times it by 2, you're going to get 6 root 2 inches. So again, back to the radicals. Those don't really go away. The last one is another where we're kind of preluding the next chapter where we talk about shapes. So a trapezoid has an area of this. And so do you know the area formula for a trapezoid? And you may not remember that from middle school. It's a good thing. Hello, good morning. The area of a trapezoid is base 1 plus base 2 times height over 2. Okay, and I'll have you learn that next chapter, but in the meantime, let's just kind of work on it together. They give you the base length of 12 of one of the bases, okay, and a height of 3, find the length of the other base. Okay, remember, trapezoid has 2 parallel sides. And so to find the area, you add those up. Take these 2 bases, and you add them. You times it by the height. The height is going to be perpendicular to that base, okay, between these 2 bases. That's the height. And then you times it, or divide by 2. So this is going to be the height. So let's plug in what we know and solve for what we don't. They give you the area, and again, we'll ignore the label. It's 124. 124, we'll just use the label when we're done, equals, and then we got base 1 is going to be 12 meters plus x. We don't know if it's base 1 or base 2, it doesn't matter. And then the height is 3 over 2. And let's solve this equation. How we solve it is we multiply both sides by 2 to cancel this out, and times this side by 2. You get 248 equals, and then we've got 12 plus x times 3, and then we should distribute. And you get, I'm running out of space. 248 equals 36 plus 3x minus 36 from both sides. I'll just go down here. And then you get 212 equals 3x, divide by 3. And your answer is going to be 70.6. And that is going to be our label we use as meters. All right, so what we're doing today was, could we find the area of a circle, pi r squared? Can we find the circumference, pi d? And then also, if you don't want to go do the whole circle, well, then take a fraction times either the area or the circumference to figure out what is that partial area or circumference of that circle. All right, thank you so much. I hope you have a great day.